Okay, so binomial radical expressions. We've got two main ones we're going to look at, and we're going to review one that y'all have done before, but it's been a little bit of time since we've done it, so we'll go from there. Okay. Um, okay. So the very first thing we're going to do, we're going to work adding and subtracting first. All right, and the big thing you need to kind of remember as we go through this one, when we're setting these up, the coefficient is going to be the number in front. And then you've got your root or your index that's here. And then your radicand is on the inside. So adding and subtracting, again, the big thing you got to remember is coefficient. That's what's in front of the radical. The index or the root is up here. The radicand is what's on the inside, because we're going to talk about all those different little parts and pieces on this thing when we talk about adding and subtracting on the stuff here. Okay, very first thing is we're going through this one that we've got to kind of have as we're going to add or subtract. The index has to be the same. So again, if we're talking about binomial, that means we're adding two things. Sometimes it may be trinomials, but the main thing is we're adding more than or subtracting more than one thing here. So the index or the indices, indexes, whatever you want to call it there, they have to be the same. So if you got one that's a square root and one that's a third root, you can't do anything with it. All right, second thing is the radicands must be the same. So first thing, index has to be the same. That's what first check. Second thing is the radicands, what's on the inside, has to be the same. And if those two things are the same, then you can go to step 3, where then you add or subtract the coefficients. Whatever the signs tell you to do, that's what you do. All right, and then the big thing on this one is when you're adding, subtracting the coefficients, here's the one thing you got to be careful of. Put it in all caps. That when you add and subtract on these, you do not change the radicand. The only thing that changes is the numbers, the coefficients that's in front. Okay, so adding, subtracting is really, if the basics of it comes down to be simple here, is that again, as long as the index is the same, the radicands are the same, you just add or subtract the numbers in front. And you can almost think about like the radicand part back here, this whole radical part being like x's and y's. That if one of them is square root of 5 and the other one is square root of 10, it's like an x and a y. If you try to add an x and a y together, they don't add together. They stay separate as you go through this. So, all right, so let's give you a few examples, make sure we got it going on. Let's go 7 on the third root of 5 minus 2 on the third root of 5. Okay, again, index is the same because we've got index 3 on both of these. Radicands are both 5. So at that point, if those things are the same, that's where you just kind of cover those two things up. You're just going to do 7 minus 2, which is 5. And again, that's like having a big, you can almost think about these as being like a giant X for each variable there. That's like 5x, but it's going to be, instead of x, it's the third root of 5. So if it's 2 squared of x, plus 6 square root of x. Okay. They don't give you an index, but again, in that case, it's understood to be a 2. So no indexes, that automatically defaults to being a 2 for the index. So they're the same. X is the same here, so it's just 2 plus 6. So that is 8 square root of x. Right. If it's 3x times the square root of xy plus 15x square root of xy. Okay. Both square roots, they're both xy, so everything's exactly the same. Again, if they're exactly the same, that's where you basically just get to ignore that and just look at the numbers. It's 3x plus 15x, and that would be 18x. Remember, it's not 18x squared. If you're adding and subtracting, you just add the numbers. You don't really do anything to the variable part. So it's 18x, and then you just stick the square root part that's on the end of it on the end of it there. Okay, I don't think they would give you a problem like this one, but just to kind of give you an idea. So if they had you like do 8 square root of x plus 9 square root of y, and they ask you to simplify that one because they're both square roots, but because that index is x and that index is y, because the radicands are different, that's one that you cannot do anything. That one you basically would say that it's already simplified. I don't know if Math Excel would give you a problem like that. If they did, they'd have to give you an option that says cannot do or not possible, or you would just type in the exact same answer again if you had one like that. Okay, so that's the basics of what we're looking at. As long as the radicands are the same, you can add the numbers in front or subtract the numbers, whatever the cases happen to be, as you're going through the coefficients. Now, here's kind of I guess this is where it kind of kicks up a little bit. If the radicands are different, and most of the times on this one, this is where we're going to be using different numbers. So for this one, think like square root of, just put the side over here. So if the radicands are different, then this will actually be the problem we'll do. So if it was like square root of 12 plus square root of 3. So you've got different radicands. That would be one of those questions where you wouldn't just say, all right, that's all we can do. But if the radicands are different, you have to simplify the radicands first. And then once you simplify the radicands, then you get to add or subtract. Yeah, so it would be nice if everyone that's got different radicands, you would just go up and simplify, it's done. But they're going to give you, and again, going back to the problem we're thinking about in this case, if you had square root of 12 plus square root of 3. All right, and do not tell me that's the square root of 15. No, no, no. That's not going to be it. Because somebody's going to do that. Hopefully that will be one that if you're going through and doing some of these that, hopefully that will help you out. It is not square root of 15. You don't just do 3 plus 12 and make it 15. That if you're going to add or subtract, the radicands have to be the same. These are different. So that means you've got to take these things and break them down a little bit. Okay, and you can do this one a couple of different ways. If you start to break this one down, if you want to do the stack or the ladder method like we did before. Now, if you want to do the factor tree, you can. 12 is even. You can divide it by 2 to get 6. 6 is even. Divide it by 2 to get 3. So if we do 12, we got a pair of 2s, right? So we know that 2 will get out. that 3 doesn't have a buddy, so it will stay on the inside. So we're going to take the 12, we're going to break it down, and as we break it down, we're going to get 2, 2, and 3. So again, exit buddies, the 2 gets out, the 3 stays on the inside. So now we've got 2 square root of 3 plus square root of 3. This one doesn't have a coefficient, but remember, if it doesn't have a coefficient or a power, you can always put an understood 1 that would be there. So this is really 2 square root of 3 plus 1 square root of 3. Now that your radicands are the same, you can just do 2 plus 1 and make that 3 square root of 3. Okay, and that's more, again, you'll get a few problems like these back here where it's already simplified for you. You just got to add your coefficients just to make sure you got it. Then once you've got it kind of the hang of that one going, then you're going to have to take these and break them down. So that's going to be the hard part, is just taking the time to take these numbers and break them down till you get what you're looking for. All right, let's do a couple more of these. Make sure everybody's okay here. Everybody good so far? All right, so for the next one, let's make the numbers a little bit bigger. I understand, great. Let's go third root of 250 and third root of 16. All right, now here's the other hint. Here's the other trick for these. If you're looking at these, you're going, I got 250. I don't want to do that. Go ahead and do the smaller number first, because a lot of times once you get the smaller number and you break it down, it's going to tell you kind of what answer you're looking for. So we're going to do the 16 first. We know it's even. We divide it by 2. 8's even. Divide it by 2. 4's even. We divide it by 2. Okay, so if you're scared of the 250, don't worry about it. We'll come back to it in a little bit because we're going to figure out what's going on here. So for 16, if we do third root of 16, it's 2 times 2 times 2 times 2. If you're good from here, again, you can just take out the 3 2's, put it on the outside. You got your 1 left over. If you're one of those you like to write them all out, then we'll go do that over here. So again, third root means we need 3 exit buddies to get out. So that gets that 2 out. That 2 doesn't have enough buddies, so he stays on the inside. All right, now here's where you can kind of help cut your work down a little bit as you're going through these. So when you go to do the bigger number, you know this one is already cube root of 2, so go ahead and do this one. Before you try to break this thing down, go ahead and put that as 2 times 125. Or we're going to do 125 times 2 if you'll do that one. And then check this number, because usually whatever this number is, this one's going to have that same thing left over. So if you take 250 divided by 2, that's 125. Then if you check that number, you're probably going to see that's going to be a perfect cube root in this case. So we're going to do the cube root of 125. And that's just 5. So we can take the 125, we can do the cube root of that, and just make that 5. So really, this thing is 5 on the third root of 2 minus 2 on the third root of 2. Okay, so now you've got 5 minus 2. So that's 3 on the third root of 2. So if you've got the bigger number and you don't worry about breaking down the bigger number, work with the smaller number first. And usually whatever that answer has, this one's going to need the same thing, because then you can add or subtract those. Now, occasionally they make it where they're 2 different ones, but most of the time That's usually a really good thing to kind of key in on that one and see what you're looking at. So, okay, so there's your adding, subtracting. You've got numbers, and again, if they happen to give you a third term out here, you do the same thing with the third term, and then you might have to add these two together and then add or subtract it to a third number that's there. But you just make sure you break them down as much as you can, and then as long as the radicands are the same, you just ignore the radicands and you just add or subtract the numbers, and then whatever the radicand is, you just put that back into the part that's there. You don't have to change anything with the radicands. Okay. Now multiplying, and we did a little bit of this last time we were doing notes. So multiplying, the only thing we're going to do different this time is instead of just doing one term times another term, we're going to do multiplying binomials. And when we're doing multiplying binomials here in this case with the radicals, that's where we're going to do the full method. Okay, so we're going to have 3 plus 2 squared to 5, and then 2 plus 4 squared to 5. All right, and again, full method is just double distributive property. So we're going to do 3 times 2, and we're going to do 3 times 4 squared to 5. So 3 times 2 is 6. 3 times 4 square root of 5 would be 3 times 4 is 12, and we'll just stick the square root of 5 on the end of it there. All right, and then distributive property with the 2 square root of 5, so we got 2 times 2 for 4 square root of 5. And then we've got 2 times 4 for 8. Okay, and remember, multiplying, then you actually multiply the stuff. So adding and subtracting, you don't change the radicands. If you're multiplying, you do change the radicands. So you do 5 times 5, and you make that the square root of 25. I think that's the big difference that you got to have as we go through this stuff. That again, if you're multiplying, you multiply everything. You multiply the outside numbers, you multiply the inside numbers. When you're adding and subtracting, you don't do anything to the inside numbers, what's in the radical. You just add or subtract the numbers on the outside. I think that's the biggest thing. If you can get that, everything else is all just easy stuff. That you just got to make sure you remember those two things are different when you go through that. Okay, so the 6 is good. Nothing there. You do have 12 square root of 5 plus 4 square root of 5. That's what we just got finished doing, that if it's 12 plus 4 square root of 5, you can do 12 plus 4 and make it 16. Okay. And then you've got 8 plus square root of 25. Well, square root of 25 is 5. So that's 6 plus 16 square root of 5 plus, and if we do 8 times 5, that's 40. And then you can add those two together to get 46. And which one you put first, it doesn't really matter. You can have 46. You can put the 16 square root of 5 at the end, or you can put the 16 square root of 5 at the beginning, and then put 46 at the end. Either one of those two that you do, either one's fine. All right, let's do at least one more multiplication. Make sure everybody's okay with it. All right, so for this one, let's go with let's do one with two. Do one with radicals everywhere. Let's do 5 square root of 2 minus 4 square root of 3, 6 square root of 2, and then 7 square root of 3. Okay, so we'll do, again, distributed property with the 5 square root of 2. So we got 5 square root of 2 here and there. So 5 times 6 is 30. And on the inside, if we do 2 times 2, that is 4. On the second one, we got 5 times 7 for 35. 2 times 3 is square root of 6. Okay, and then distributed property with the 4 square root of 3. So we got negative 4 times 6 is negative 24 square root of 6. Negative 4 times 7 is negative 28 square root of 9. Okay. Again, multiplying, you multiply everything. You multiply the outside numbers together, you multiply the inside numbers together. And then should have a bunch of stuff to break down right here. We've got 30 times square root of 4. Well, that's 30 times 2. So that's 60. These two, that's our adding and subtracting because we've got both of them are square root of 6. So we can just do 35 minus 24. Well, that would be 11 square root of 6. All right. And at the end, we've got 28 times square root of 9. Well, that's negative 28 times 3, which would be negative 84. Okay. And then you've got these two you can put together. So we've got 60 minus 84. So again, you can either leave the 11 square root of 6 there. You can either put the negative 24 in front or you can put it behind it, which where you put it, again, it doesn't matter. So it's negative 24 plus 11 square root of 6, or you can do 11 square root of 6 minus 24. Either way that you go from that one's just fine. Okay, and then last thing we've got. So add, subtracting, pretty much same thing. Multiplying, again, we did the multiplying yesterday, just now we've got more terms. Not as many variables in this one, it's more just numbers than what we're doing for the parts. And then the last thing we got to do is division. Okay, so with division, for this one, basically there's like 3 things you got to do here. You're going to divide the radicals, or the radicands, sorry, radicands. Oops. Now, when you're dividing on these, a lot of times you may not actually be doing division. It's more of you got to think that you're simplifying fractions. That sometimes you're dividing, the bottom number and the top number, but a lot of times you're going to take the 2 numbers you have and you're going to divide them both by 3, or you're going to divide them by 5 or something. So it may just be a fraction when you get finished with it. So just think simplifying fractions on this one. All right, second thing is, if you have variables, you have to subtract the exponents. So last time we were working through things with multiplication, you added the exponents. So division, you do the opposite, you subtract the exponents. Okay, and then once you've done those 2 things, then you simplify if it's possible. Probably in a lot of cases not, but sometimes you may look at something and you go, oh, well, I can simplify that answer, and then you do that, and then you just do what you can do with it there. Okay, so here's some problems that you'll have for division. Again, start off easy and we'll build up a little bit as we go. Okay, so we've got square root of 200 over 2. And a lot of times on these, if they give you two separate fractions, you can basically think about putting this thing together as one big fraction. So what is 200 divided by 2? It's just 100, right? What's the square root of 100? Square root of 100 should be 10, right? Because 10 squared, 10 times 10 would get you 100. So if you've got 10 squared, square root of 100 should just be 10 for that thing. All right, now, again, a lot of times square roots are a lot easier because that's the stuff we're used to working with. If we give you one that's not in square roots, let's give you a third root one. Let's do third root of 81 over third root of 3. Okay, so basically it's just 81 divided by 3. Now in that case, 3 will actually go into 81, so that we get a number out of it. So it's third root of 27. And on these numbers, when you get it down to a certain number, then always check it, because a lot of times on these you may get a perfect cube number. So if we do the third root of 27, then that to be just a 3. Okay, do another third root one. Okay, so let's do 250 on top, or 257 x to the 7th y to the 3rd. On the bottom, we've got 2x squared y, and everything is third root here. Okay, so this is one you almost want to do it like in different pieces. So you've got the third root of 250 divided by 2, which would be third root of 125. And then for the x's, this is where we're going to do 7 divided by, or 7 minus 2. So we'll do 7 minus 2 to make that x to the 5th. And then for the y's, just have to remember that there is technically a 1 there. So then it's 3 minus 1 to make it y squared. So we're going to take 250 divided by 2 to get 125. We've got x to the 5th and y to the 2nd. And then this is where, again, once you've got these, subtracted these variables to get here, this is where you're going to take 5 and divide it by 3. So for x, we're going to take 5 and divide it by 3. And for the y's, we're going to take 2 and then divide it by 3. Okay. And again, that's where we're going to check. Now, we actually did this one earlier. If you do the third root of 125, that comes out to be just a plain old 5. So we don't have to do anything with this part. That answer is just 5. Okay, with the x's, though, this is where we got to take 3 and divide it into 5 to figure out how many go outside and how many go inside when we go through this one. So 3 go into 5 one time, with 2 left over. For the y's, you've got to divide 3 into 2. Well, 3, it's a fraction already. There's not a number bigger on top, so it won't go. So that means nothing gets out. So we've still got 2 left over on the inside. So again, this is how many variables get out on top. And this is how many variables are left over on the inside when we get finished. Okay, so the 5 was outside. We've got to get 1x on the outside. No y's get out. There was nothing left for the number on the inside. It was just the 5. So on the inside, we've got to have 2 x's and then 2 y's. Okay, so everything we're doing today is going back to the stuff that we did the last 2 days. Either sometimes we get a perfect radical that breaks out and it's all there, or you get some like this where it's not, and we have to do something different. Do you remember rationalizing square roots? Maybe, maybe not. If I show you one, you probably remember. This is back when we were doing the unit circle stuff. That if we wind up and we had 2 over the square root of 3, that we gave you the shortcut. That the shortcut was you would just take the number, whatever the top part is, it's good. You move the square root from the bottom to the top. And then on the bottom, you leave the square root off and just give me the number. Okay, so if they gave you something like 4 over the square root of x, then again, the shortcut is you basically leave the top number the same. You move whatever the square root is from the bottom to the top. And on the bottom, you give me whatever you've got, but you leave just the radicand on the bottom without the square root, so it's just 4 square root of x over x. Okay, now if you throw in numbers, you have to go like an extra step sometime on numbers because some of these, you still do the exact same thing. So if they ask you to rationalize 70 over the square root of 2, still got the 70, you move the square root of 2 from the bottom to the top. On the bottom, you give me the 2 without the square root, so it's just a plain old 2 on the bottom. But what's 70 divided by 2? We can simplify that, right? Divided by both by 2, so it makes it 35. And then square root 2. Now, sometimes people ask, why can't I just cancel these 2's? Well, the only way you can cancel is that you got to have both of them square roots. If this one's a square root and this one's not, there's nothing you can do to simplify those 2. If they're both outside the square roots, then that's the part you can simplify. So if you got any other index greater than 2, you got a separate way you have to kind of do this one. You got to multiply by the radical of the denominator. And this is the part where it's a little bit kind of funny the way we say this, but it's just got to hang on here. It's easier to see it than it is to say it. With a power of the radicand needed to be the same as the index. And I realize that's a terrible sentence that's there. But when we show you one, it'll be easier when we show you what the problem is, because sometimes explaining it's not the best in the world. Okay, so if it's 10 over the 7th root of x squared, that on the bottom, if this was the seventh root of x to the seventh, that's what we're trying to get. So we want these two things to be the same so they would cancel each other out and just make it one. And that's what we're trying to do for this one. So here's all you have to do. You're going to take whatever the original problem is, and you're going to multiply, and here's all you have to do. You just have to subtract these two numbers. 7 minus 2 is 5, so we're going to multiply by x to the fifth. But again, it has to say seventh root because if you're multiplying, the indexes have to be the same. Okay, so what we're going to wind up doing is it's similar to the other part. We're still going to have the 10 on the top. We're going to move this seventh root of x to the top, but instead of putting the exact same thing, this is where you're going to subtract these two, so now it's just going to be x to the fifth. And on the bottom, that's where we're going to cancel these two things out, because if you do these two together, that's going to be the seventh root of x to the seventh, but that cancels out, and that's just going to give you a x on the bottom. So it's just like with square roots. The difference is when you move that radical to the top, it's not the exact same numbers. You've got to subtract these two numbers. And when you subtract those two numbers, that's what you're going to put on the inside. So it's got a shortcut. It's just not as easy as the other one was. Because again, when you do this one, you're going to subtract these two numbers, and that's what you got to put on the top of it there. All right, one more just to make sure we got it, and then we'll wrap this thing up. Okay, so we're going to do the 8 over the 10th root of b to the third. All right, and again, here's where we're going to kind of borrow what we did before with the shortcut. We've got the 8 that's on top. That's going to be there. We're going to move the 10th root of b up here. The only difference is that the number you need here is when you subtract those two numbers. So 10 minus 3 is b to the 7th. And on the bottom, then you can give me just the variable, whatever it was, you can cancel out your powers and just make that a b.